In this video, we are going to look at graphs and describe the stories that these graphs tell us. Let's jump right into it. We are given a title for this graph that kind of tells us what's going on. We're told that we are biking to the park. That's the situation. On the vertical axis right here, we're told that these values measure the distance in miles that we are. And maybe that's distance in miles that we've biked. And then the time in minutes that we've spent biking. So we're going to actually tell the story that this graph says. There are multiple ways to answer these kinds of questions. Your teacher might ask you to describe the graph. They might say, tell the story of what the graph says. It's a number of ways to even give instructions for it. So I'm going to give you just a couple of interpretations. One way to describe it is you can kind of make up a story. It's kind of fun. You look at the graph and you think, well, I started out having biked no distance at 0. And then over about 1 minute time, I bike 0.2 miles at a pretty quick pace. And we know it's pretty quick because you see how the line is relatively steep compared to this line here. Then we stop and we see a really cool, I don't know, deer, right? Or a rabbit. And we stop and look at it for about 1 minute. Then from there, we start biking again, but we're not biking as quickly as we were before. We can tell this because the line right here is not going up as steeply. So over about a minute's time, the same amount of time here, we have not gone as much distance. In fact, we've gone about half the distance, 0.1 miles. Then we stop just to rest for, roughly 15 to 30 seconds. That's a rough estimate. Then, realizing that we've spent a decent amount of time resting, we then bike as hard as we possibly can. We pedal very quickly. Again, you can tell we're pedaling quickly because the line is pretty steep compared to this line right here. So over a span of about 30 seconds, we've gone about 0.2 miles or so. 30 seconds, 0.2 miles. Then we've gotten to the park and we stay at the park for, well, a much longer amount of time. That's where the graph stops. We can tell that we're stopped where we have horizontal lines because time is moving on and there's no distance changing. That's the definition of stopping. So that's one way of kind of making up the story of what's going on. You could be a little drier about it, right? So you could look at it and say, we're biking at a very quick speed. We know that because the line is pretty steep. And then here we're not biking at all because the distance is not changing as time goes on. Then we're biking at a pretty slow rate or a pretty slow speed because the amount of distance changing is not as much as it was here, even though the amount of time is about the same. Or you could just say the line is not as steeply drawn. Then we are not gaining any distance at all. We know that because we have a horizontal line and time is going on. Then we bike at a pretty rapid rate. We know that because the line gets pretty steep. And then we arrive at the park and stop. We know that because, again, we are not biking at any rate. Since we have a flat line, no distance is changing. So multiple ways you could describe these stories. The key idea here is being able to basically look at the lines and their steepness and determine if you're going quicker or slower and if you're stopped. That's the main idea in terms of interpreting these problems. I've got a second problem here for you, and this is another classic kind of problem you will likely see, which is the distance you are away from a certain place, right? Not the total distance you've traveled, but the distance you are away from something. And you could have graphs that don't describe distance. I just figured I'd show you two classic examples, and distance and time, graphing those is a hallmark, right? A cornerstone of algebra, pre-algebra, and even courses before that. Okay, so you've got on the vertical axis here the distance you are from home, and that is measured in miles, 2, 4, 6, 8, and 10. And then on the horizontal axis, you have the time that you've been traveling in minutes, in increments of 5 minutes. And then the title tells you this is a bus ride home. Maybe we're going from school, maybe we're going from the mall on a public transit bus, who knows? But we start at 8 miles away from home. We know that because no time has gone by, and I guess I could put a 0 here. No time has elapsed and you're there. We get onto the bus and perhaps we're just waiting for the bus to take off. It's just waiting at school, waiting at the station, wherever it is. We know that we're waiting because no mileage has changed, yet 5 minutes have gone by. Then the bus starts out and goes at a relatively slow pace. And we know that because the steepness, it's not too steep, but we've gone about 1.5 miles closer to home. Then maybe the bus stops for a little bit. There's some heavy traffic, construction, and we're just waiting. Or maybe we go to a bus stop and we wait there. So we know that because there's a horizontal line. No distance has changed, yet time has gone on. Then maybe the bus is kind of crawling along. There's some heavy traffic. We know that we're not going as quickly here because the line is not quite as steep. So about 5, 6, or 7 minutes have gone by, and really only about a distance of a mile or so has changed. Then we stop for a little while. Perhaps we're stopped at a red light, or we're in traffic just for a minute, minute and a half or so. We know we're stopped again because distance is not changing and time is going on. Then the bus might get onto a highway, or there's no lights for a while, and they speed up. We know we're going faster and getting closer to your house because the distance is getting less in a very quick rate, right? So we've gained, I would say, 3 more miles towards your house in a span of just a few minutes. We're going quicker than we were here and here. You can tell that by the steepness of the line. Then maybe we get to a bus stop. We stop for a little while, just for a couple of minutes, letting students off the bus. Maybe we're waiting for some reason, maybe there's traffic, who knows? But our distance is not changing, so we're not getting any closer to home nor further away. And at that point, no distance is changing, but time is. And finally, the bus goes at a pretty quick rate, represented by a pretty quick line and its steepness, and we get home. And we know that we're home because the distance from home is now 0, and I have this horizontal line there representing that we don't just sit on the bus, we're probably going to get off the bus and be at home. So that's one way to interpret that graph. Again, there's many, many ways to look at it. I'll reiterate, you're looking at steepness of lines. Overall, when you have a line that is not so steep, whether it's going down or going up, going down represents that you have less of whatever is on the vertical axis. Going up represents you're gaining more of whatever's on the vertical axis. If you have a steeper line, you're gaining or losing more of what we are measuring on the vertical axis over a certain amount of time. If you have a horizontal line here, it means you're not gaining any of what you're measuring on that vertical axis, even though time's going on. And finally, if you have a line that's not that steep, it means that you've slowed down. You're not quite traveling or accumulating money or whatever that y-axis, the vertical axis, is measuring, is not quite as quick. So we're going down or up, in this case, at a slower pace. Those are the key ideas. These problems sometimes make people a little uncomfortable because they're open-ended, meaning your answer might sound a little different than mine, but as long as you have those key ideas of the pacing, the steepness of lines, then you're going to be in great shape.